Okay, hello everybody. Welcome to today's Book of the Day show. I have an extremely special guest, Professor Richard Dawkins, and we are talking on the selfish gene, which, among many of his books, is a best-selling book, sold several million copies, and is one of my favorite books. I've ranked it on my Book of the Day top 150 recommended in my top five. And so thank you for being on the call from, where are you today? In Oxford?
In Oxford, yes.
Awesome. Well, this is very special, and I like to just jump right in to kind of the juiciest part, eat the dessert first, if you will,
Okay.
Professor Dawkins. So, I might bounce around a little bit, but what I wanted to start with is this concept that you talk about in the book of why humans have brains like we do. And one of them you say is so we can simulate the future without actually having to go through all the trial and error ourselves. Because you say, trial and error takes time and is deadly. Um, do you think, if you could talk a little bit about that, because that's kind of the central thesis of this book of the day, how can we use our brains? Warren Buffett says, we only learn through mistakes, but they don't have to be ours.
Well, yes. I mean, brains, of course, go back a long way in evolution, and not all brains do that. Human brains are perhaps a bit unusual in the ability to simulate the future, to do vicarious errors instead of real errors that lead to death. So when brains first started, I suppose you could say animals were programmed to do whatever was on average best for their survival. And then a bit later, they progressed on to learning, where they could actually change as a consequence of experience of the past within their own lifetime. And then the next stage, which is the one you're talking about, is when they didn't even have to experience things. You could experience things vicariously in your imagination. Run a simulation, a what-if calculation. What if I did this? What if I did that? Set up a scenario, and then avoid actually endangering yourself by running the simulation vicarious in your head. That's something that humans do very well. It may be something that one or two other advanced mammals do, and perhaps birds do, but it's something that came probably rather late in evolution.
Now, do you think this ability to simulate, you speak of a flight simulator or a general. Do you think, and this is just kind of a random question, are smarter people simply better at doing this, or is it kind of innate to all humans? We have a generally equal ability to simulate the future. Because in my experience in life, whether it be in business or personal, my biggest regrets are those where I didn't just go, oh, someone else said not looking both ways before crossing the street is dangerous. Let me just take them at their word and let me not have to get hit by a car. But I find it prevalent among people where they pride themselves on their mistakes and they go, well, I had to go through that so I could learn. But if I hear you right, you're saying it's almost innately human to not have to do that, to not have to get hit by a car, to
I
say,
mean, I'm sure, like everything else, there's variation, and I'm sure that although all humans can do it, obviously we vary in everything else. There's no reason why we shouldn't vary in the ability to simulate. And some people are much more imaginative than others, and so I don't think I would agree that everybody is the same in this.
yeah, yeah. Well, I definitely see in my own personal experience, which obviously is somewhat anecdotal about it, but awesome. Let's move to this next subject because I have so many written down. If hopefully we're not jumping around too quickly, I'm going to hit you with lots of different things. By the way, my favorite accolade that you have is you won the number one in a survey. You were considered the number one intellectual in the world. I thought that was a nice one to have.
Well, yeah, okay, I think that's a bit of a joke, but that was nice to have, yes. They didn't even put me on the list for voting the following year, so I didn't have a chance the following year. It's true that I was voted that in one year. I think it was 2013.
Yeah. Well, that's good. You say on this simulation, I wrote down a note in your book. You said survival machines that can simulate the future are one jump ahead of survival machines who can only learn on the basis of overt trial and error. The trouble with overt trial is that it takes time and energy. The trouble with overt error is that it is often fatal. Simulation is both safer and faster. That may have been my favorite part in the whole book.
Well, I had forgotten it, but it's the part that you brought up first, and yes, I would certainly stand by that. I agree with that.
I like, and for people not familiar with the book, The Selfish Gene, when you refer the phrase survival machines, you're referring to us humans in the sense that we're made up of these replicators, which you call, which are our genes, and I'm correct, survival machines is what we are.
Yes, not just us, but us in the sense of all living creatures, every body, every animal, every plant, every bacterium, every tree is a survival machine for the genes that ride inside it.
Right. Okay, next, let's talk a little bit about this concept of tit for tat, the sense that there are strategies that we can use both from an evolutionary standpoint, but also I think these apply in how we relate to other people socially. So the concept, if someone's not familiar in this game theory, is you can explain it better, but when somebody acts one way to us, we fall in one of three categories. We can be a sucker, which means we are taken advantage of. We can be a cheater. We can be the one taking advantage. Or we can be a grudger, where we act nicely until somebody does something wrong. Then we use our memory to hold a grudge against them. How does this relate in everyday life, this concept, not just at a cellular and genetic level, but in our behaviors?
Game theory of that kind originated in human sociology and human psychology and human economics. So it comes from humans and was imported into biological evolution theory, mostly by John Maynard Smith. And in The Selfish Gene, I was talking about it as a biologist. It is a very powerful mathematical theory for handling cooperation among not just humans, but all sorts of other creatures. When you come to humans, it's probably a lot more complicated than just the very simple cheats and suckers and grudges model that I proposed. I actually proposed that for the very simple case of birds who have fleas or parasites, say lice, and have to borrow each other's beaks in order to get rid of them because they can't reach the tops of their heads. So although they can groom most of their feathers and get rid of the lice, they can't get rid of those on the tops of their heads, and so it's a you scratch my top of head, I'll scratch yours. That's a very, very simple model, but that simple game theory model can be generalized to all sorts of much more complicated situations, which is what human cooperation mostly is. A mathematical model like that is helpful to get the basic idea, but then you need to elaborate it and make it much more complicated, especially for humans.
One of my mentors told me, he said, Tai, if you're playing poker, after 30 minutes, if you're not sure who the sucker at the table is, you're the sucker.
Yes, okay, that's a nice one. I've never actually played poker, but I can imagine what that would mean.
Yeah, I think socially life, somewhat falls that way. I think
Yes.
I was reading about game theory. I think it might be referred in your book in the sense that one of the best strategies is start out night. Oh, this is, I think, Dr. David Buss, who's a professor of evolutionary psychology at University of Austin, and he says,
Yes. Yes.
Start out nice and then reciprocate.
Yes. That is tit for tat. It's an extremely simple strategy. Start out nice and then reciprocate. And reciprocation kind of looks like paying back. And so if the other person does something not nice, then if you reciprocate, that is, you can think of that as payback.
He said there's a few exceptions. For example, if you're in a room where everybody's a thief, then he said you don't always start out nice. But in general situations, I thought that was
Yes.
interesting.
Yes.
Interesting. Okay, ESS. Let's talk about that for a second. Evolutionary stable strategies. I find this fascinating in the sense that the world, I mean, in capitalistic markets, if you study economics and the stock market, there's this concept of equilibrium, that supply and demand. If people want a lot of hamburgers, enough fast food restaurants, McDonald's, Burger Kings, and so on will arise to meet the demand. And if there's too many stores and not enough people, some will go out of business. So this is an economic concept, somewhat similar this ESS. How does ESS affect us at a biological level? What does it mean that we're seeking evolutionary stable strategies?
Natural selection expects that animals will do what's best for their own survival, but what's best for their own survival may depend upon what the majority of the population are doing. So if you imagine a population of seagulls, say, where most of them are fishing for fish, but a minority of them are specializing in stealing fish from the honest fishers. So we have pirates who steal fish, and we have fishers who actually fish for fish. Now, what's the best strategy? The answer is that whichever is in the majority is likely to be exploited by the other. So if the population is entirely dominated by honest fishers, then natural selection will favor pirates because there's plenty of fish to be had by piracy. That would mean that natural selection favoring pirates means the pirates will become more and more numerous in the population as the generations go by. And that would mean that when the population is entirely dominated by pirates, there are no fish to be had. And now natural selection will favor honest fishing. Well, you might think it would go oscillating between domination by fishing and dominated by piracy. Actually, it will settle down to some equilibrium frequency. It might be 10% pirates and 90% honest fishers. That's just a made-up figure. But whatever it is, natural selection will stabilize the proportion, equilibrium frequency, by favoring whichever one is less than the equilibrium frequency.
Now, this has implications somewhat similar to game theory in the sense that
Game theory. That is game theory.
Okay, so it's a game theory, another term for it. Now, what's the implications for, let's say, in society? There's this thought. There was a movie, American Sniper, which came out. It was a somewhat controversial movie about a sniper in the U.S. Army, military in Iraq, and there's a line, I don't remember exactly, but the father says, there are wolves and there are people. So he kind of said, it was a little bit similar to this. There's, if you don't know who the sucker in the room, you're the sucker. There will be suckers. There will be everyday citizens, and there are criminals. Are criminals an extension of this theory in our everyday life, in the sense that there are people who are honest working, hardworking people, and then there are people, a small percentage. You're never going to have 80% thieves, because there has to be somebody producing the goods. But does this extend into these social things that we run into in life that drive us crazy, whether it be a cheating husband or wife, somebody who burglarizes your house, and so on?
I think it does. The ESS puts it into an evolutionary context where what happens is that frequencies change in the population. But you're quite right that there is an analogy with a minority of criminals in society. Humans, of course, are far more complicated because humans have policing. We have police forces who keep an eye on us, and so that's something which you don't get, at least in not any simple way, in biological nature.
Now we have things like, for example, parasites are interesting. I actually lived on a farm. I lived with the Amish for a couple years, and I lived on a farm for 8 or 10 years. And you see there, if you have sheep or cows, every farmer is dealing with parasites. And the parasites have this balance they want to maintain. They want to take some health and nutrients from the animal, but they don't want to kill the animal, because when the animal dies, generally the parasite can't move to another host very easily. And that would be defined also in this ESS.
Yes, that's a very good point. And it depends a bit upon how the parasite leaves its present host. If the parasite, if the method of exiting from the present host is via the present host's own offspring, if the parasite travels to the next generation, say in the eggs of the host, then it will really, really have the interest of the host at heart. Everything that the parasite wants, I'm using the word wants in quotes there, everything the parasite wants will be pretty much identical to what the host wants. The parasite in that case will, quote, want to keep the host alive as long as possible. If, on the other hand, it's the kind of parasite which they multiplies hugely inside the host and then makes the host burst into a great explosion and spread spores all over the countryside,
Right.
then that's a quite different thing. That would be, in that case, the interests of the parasite and host would be very different, and the parasite in that case would kill the host, as of course parasites sometimes do.
Interesting. Let's talk about something that sometimes people consider controversial. I know that you don't, but the United States is a pretty religious country. A lot of the world is very religious. And you define in the book, your best-selling book, The Selfish Gene, you say, we are survival machines. Robot vehicles blindly programmed to preserve the selfish molecules known as genes. This is a truth which still fills me with astonishment. That's what you say. And that, so from your standpoint, this blind programming that sees us not as necessarily divinely created beings, this makes you excited or astonished. A lot of people see that as an affront to everything they believe about life. And I know we can talk about this for a long time, but what's your simple reply to people who say, well, if this is true, how do you find meaning in life? If we're just robots blindly going around this planet, what keeps us from falling into, evil Hitler-like thinking where we're just survival of the fittest and extermination of handicapped people? And so I'm sure you get led down this kind of trail of
Yes. I've often said that although I'm a passionate Darwinian when it comes to explaining the whole of life, including human life, I'm a passionate Darwinian when it comes to explaining why we exist, why we're the way we are. I'm a passionate anti-Darwinian when it comes to constructing societies. So politically and socially, I want to live in a society which is as un-Darwinian as possible. I want to live in a society where we sit down together and discuss the kind of society we want to live in, where we vote for the kind of government we want. And we do not, at least in my case, we do not vote for a Darwinian style of government, which is, as you say, selfish and ruthless, and not the kind of society in which I wish to live. We do not have to say, just because nature is this way, we have to be that way as well. We can construct a society of friendship and cooperation, which is a very un-Darwinian society. And that's the kind of society I want to live in.
Is there a way to do, this goal of a non-Darwinian society, but still understand our roots as selfish creatures. For example, people who are very pro capitalism, they would say, look, capitalism has an element of Darwinianism in that leave the markets to sort themselves out. And while no country really is truly capitalistic, we tend to add some level of social control. That would be an example of a hybrid sort of Darwinianism tempered by some human regulation. Is that how you see?
Yes, I mean, I could easily imagine that somebody could have a political philosophy which was a kind of humane capitalism, and which took the view that a humane society will automatically arise if the market is allowed free rein. I don't subscribe to that political view myself, but I don't think it's automatically horrible in the way that a truly Darwinian society would be.
So you would believe more in market control. You wouldn't leave it as much to the human spirit, so to speak.
Well, I think, I mean, I could imagine a defense being made of a market-driven society as being one that actually does lead to greater prosperity. As I said, I don't think I would subscribe to it myself. I think I'm rather more in favor of a controlled society, but I have a deal of sympathy with friends of mine who believe that a just and humane society will automatically arise if the market is allowed freedom in a sort of Adam Smith way.
Right. Interesting. Very interesting. It's interesting to hear from you because I would think maybe you'd be a little more Darwinian, but that's interesting to hear. Great. Let's talk about you say here, it is a simple logical truth that short of mass emigration into space, with rockets taking off at a rate of several million per second, uncontrolled birth rates are bound to lead to horribly increased death rates. It's hard to believe that this simple truth is not understood by those leaders who forbid their followers to use effective contraceptive, aka birth control. Thanks for us. So you say there is a natural method. It's called starvation for population limitation if humans don't do this. When you say this, is it various religions, Catholicism, and others that butt up against you?
Well, yes, it is, and that's what I had in mind when I wrote that. However, it is also true that that really does apply if there is uncontrolled birth rate, uncontrolled reproduction, and but what actually happens is that the more prosperity there is in a country, the more people do adopt birth control. So although theoretically the Roman Catholic Church is against contraception, in fact, if you look at countries which are dominated by the Roman Catholic Church, if they're prosperous, then they use birth control as much as anybody else. So countries like France and Italy simply ignore the Roman Catholic Church and get on with birth control.
Do you think that's because, going back to this very root concept in the book, humans, I think Sam Harris wrote a book, he writes a book saying, and Stephen Hawking kind of agrees that free will is somewhat an illusion in the sense that we're driven at a cellular or genetic level, as you speak of in this book, and our genes know that they're selfish, so they don't want to put themselves in an environment where they will starve to death. Is that why you think this French and Italian lower birth rate happens? Because they're driven at this innate level. We somehow understand, almost instinctually, these things.
I think I would be cautious about I know you don't literally mean genes know what's good for them, but it is tempting, the rhetoric that I used in the selfish gene is tempting to mislead in that kind of way. I think I would rather say that our brains, going back to your original question, our brains have become so big and so good at simulating the future, so good at imagining. We can look into the future with our brains and see what the bad consequences of over-reproduction would be. We can actually look into the future. And that's something that is new, something that in most of the evolutionary history hasn't been possible.
Yeah. Now, food systems along this line of overpopulation and starvation. There's a lot of controversy in the EU and the United States on genetically modified organisms. Of course, this has somewhat is in your. I know it's not your main area of expertise, but it's related in the sense that when you genetically modify organisms, you're going to the root of what makes living creatures, alive. What's your feeling on genetic modification, whether it be in food systems or just in general, ethically and with your expertise in genetics? And I think is it an ethologist? Is that what you're referred to?
I think I'm not sure that it's really an ethical question about genetically modified foods. I think it's a question of prudence, really. It could be an unwise thing to do. It could be that things could go terribly wrong. In science, I think we do need to, in the application of science, we do need to apply precautionary principles and take care that anything we do doesn't have adverse consequences. Once again, imagine the future, simulate the future, imagine the things that could possibly go wrong. So I'm not sure it's a question of ethics as much as a question of prudence. And I think the dangers of genetic modification may have been somewhat exaggerated, but I'm not in favor of a kind of gung-ho, just do anything that we want to because we can. I think it is important to exercise prudence, exercise precautions.
Yeah. I would agree. I mean, as you read books like yours, The Selfish Gene, you see this. It is a very complicated set of mechanisms going on at a genetic level, and it's probably going to take us a while to figure out how to reverse engineer them. It's not super easy.
No, that's right. It's very difficult to know. I mean, if you wanted to create an organism that was good for some particular purpose, it's very hard to know how to do it. It theoretically probably could be done, but it's much more complicated than many people realize, exactly as you say.
Yeah, interesting. Now, let's talk about on a personal level. I always say that we humans are juggling four balls at one time, at least consciously. Subconsciously, this could be argued. Most humans want to be physically healthy. They want to be financially secure in the modern world. That's money. It used to be resources. We want to have love in the form of healthy social connections, and we want some feeling of happiness. Could you speak on happiness from the standpoint, maybe a little more scientific and genetic standpoint? What purpose do you see happiness serving in? And maybe the practical question, can we be happy? What can we do knowing that we're somewhat these, as you refer to, survival machines with these replicators, which sounds so...
At a very crude level, if we're talking Darwinism, I suppose that happiness is the state that the body is in when it's doing things which are likely to lead to its survival. And unhappiness, an extreme form would be pain, is the state the body's in when it's doing something which is likely to lead to its death. So pain is a kind of warning that says, don't do that again. If you do something like pick up a red-hot coal, you feel intense pain, and you're not going to do that again. You learn not to do that again. If you persistently did things that lead to pain, then you're likely to die. And so natural selection has favored brains which don't repeat things that are dangerous. On the other side, on happiness, natural selection has favored brains that do repeat things that gives them a good feeling. So something like satisfying hunger, satisfying sexual desire, satisfying thirst, these are being warm and comfortable. These are all things that make us feel good, make us feel happy, and they are also things which statistically are more likely to lead to our survival. That's, as I say, at a very mundane level, but happiness in humans has sort of taken off into the stratosphere of advanced things like happiness at listening to beautiful music and reading beautiful poetry, seeing a beautiful sunset. These are all probably very peculiarly human things which have taken the concept of happiness and run with it in directions which are not so easy to understand in a simple, naive, Darwinian way.
Yeah, do you think, it's interesting. I think it was Sigmund Freud who said the mind is like an iceberg, 90% of it is below the surface in our subconscious. It seems that we do things that mitigate or work against our momentary happiness, whether it be we know we shouldn't eat. I'm sorry, they work against our long-term happiness. We eat a donut even though we know at a conscious level we shouldn't, that it's going to make us unhappy when we look at our belly growing. And so it seems it seems like some of that could be explained in an evolutionary cycle. We're doing this because of our genes. Now they don't want, but our genes are operating as a fashion to survive and replicate. But now it's more complicated because...
Yes, that's a very good point. And I think the way to understand that is to say that what our genes built into our brains was rules of thumb which worked at an earlier time in our history when we were hunter-gatherers on the African savanna. Something like our love of sugar, which you just alluded to. Because sweet things were difficult to get, I mean, honey would have been the only real way of getting extremely sweet things. Fruits were available to and generally good for you. If you live in a world where it's pretty much impossible to get too much sugar, then a rule of thumb that says get as much sugar as you can would work, would improve your survival. Nowadays, we live in a world where we just simply buy sugar in the shop and buy sweets and chocolates and donuts and things. Nowadays, we live in a world where the original rule of thumb, which is eat as much sugar as you can, no longer promotes our survival. It does the reverse. But the rule of thumb is still there. This concept of a rule of thumb, I think, is very important because, after all, the rule of thumb that says, like sex, enjoy sex, again, in our wild ancestors, that worked because sex led to reproduction, and reproduction was what it was all about. Nowadays, as like as not, we are using a contraceptive, and so that the desire for sex no longer has its biological function anymore, but we still desire it because the rule of thumb is built into our brains.
Now, okay, this brings up an interesting point. One of my favorite books, and another one in my top 5, is Sigmund Freud wrote a book that hasn't been read too often. It's a fairly complicated read. You may have read it. It's called Civilization and Its Discontents. And he goes through his take on why we're happy and unhappy. And basically, you can boil it down to our genes are saying X will make us happy, and civilization is saying Y. So you brought up the example of reproducing and sleeping with people. So our genes are saying, you take a 21-year-old boy, man in the world, he has this genetic programming to go out, sleep with as many women, but civilization is somewhat more monogamy and marry one person. So Freud says basically we'll never be fully happy. Do you think that there's truth to that?
Yes, the idea that we'll never be fully happy because there'll always be more of an effort that we could put into it. Is that what you mean? We're constantly being driven to do more. You could never relax. You could never just sit back and just bask in pleasure.
Well, that and that society has set up things, for example, that will not allow us to express our genes, in the sense that your genes say, as a man, sleep with the most women to maximize your great grandchildren, where society says no, you can marry one. So there's almost this war between our genes.
I see what you mean. Yes,
Yeah.
I think that is true, and we're constantly coming back to humans are very complex, and the selfish gene is actually not mostly about humans. It's about life in general. And I think you have to understand how life in general works, which is what the book's mostly about. And then you come on to humans, and you have to, as it were, treat humans in a more sophisticated way. We evolved by natural selection in the same way as every other living creature on Earth. But we have these much more complicated brains, and we have a complicated society. And society does impose restrictions and rules which may conflict with our own desires.
Yeah, interesting. Let's talk about something that applies at the genetic level in general, applies to multiple species, and you hear it talked about a lot. Nature versus nurture. And there's schools of thought. Where do you stand? What part of behavior is just somewhat inherent, and what part is learned by the environment? Is it 50-50? I know that's an oversimplification, but how do you see it?
It's an oversimplification because it varies for different things. What could that possibly mean when you put a figure like 50-50? What it really refers to is the variation in the population. To what extent can you predict the variation in the population if you know about genes and if you don't know about genes? Now, the best way to test this is by looking at twin studies. That means you take monozygotic twins, identical twins, and you take dizygotic twins, non-identical twins, and you know that monozygotic twins have twice as many genes in common where it matters than dizygotic genes. And you have a few cases where twins have been reared apart for one reason or another. They've been separated at birth, so they've had different environments. And if you compare how similar identical twins are to each other versus fraternal twins, non-identical twins, and if you compare both sets of twins reared apart versus reared together, you can come up with a figure, the so-called heritability, which is often expressed as a percentage, like 50%, as you suggested. And it varies a lot, and things like height has a very high heritability. Weight would have a lower heritability because it might depend upon how much they've eaten. Musical ability has high heritability. Mathematical ability has high heritability. Other things have low heritability. And so it is an interesting question. It's a question that you can answer by doing either twin studies or something equivalent to twin studies. And so there's no general answer to the question.
That's interesting. So some things I didn't know. Music is. I think Bach had 23 children, and a lot of them were great musicians. So that high heritability.
And his father was.
Yes. Now, one of the fascinating things in the book that goes right along with this subject of nature versus nurture is you have this concept which why, and I'll oversimplify here. I probably shouldn't be oversimplifying what you're saying, but one of the questions is why do humans and not just humans, but species reproduce sexually as opposed to just like ferns or something? And you call this, I think, the bottleneck. I found this fascinating, and 3 reasons So the bottleneck is could be understood maybe as humans. We all start out as this one cell, and we grow from little babies. We don't just cut our arms off and another human kind of sprouts out of our arm without having to go through the full reproductive cycle. And this is in the chapter, The Long Reach of the Gene. And you go through three main reasons that we do that. Why? Can you kind of speak on this subject?
It's a very, I think this wasn't in the original first edition of The Selfish Gene. This was actually in my second book, The Extended Phenotype, which is for my professional colleagues. And the idea of the bottleneck is that unlike, say, a plant where you can propagate a plant by taking a cutting, you can take a bit of a leaf and stick it in the ground, or a bit of a stem and stick it in the ground, and it will grow a new one. Animals, on the whole, don't do that. Animals go to a bottleneck, a single cell, which contains all the genes which are going to give rise to a new creature. Now, the effect of the bottleneck is that every single gene in the full body, say a human body or a hippopotamus's body, every gene has only one way of getting into the future, and that is through the sperms or eggs. That's the bottleneck. And so there is total cooperation between all the genes because they all have the same expectation of how to get into the future via the bottleneck. If they reproduced like plants, where you just chop off a bit of an arm and stick the arm in the ground and something, and it grows into a new hippopotamus, it wouldn't be like that, because then genes in the arm would have a different aim from genes in the leg. It's because of the bottleneck that we can expect that the entire... sorry, my wife's just arrived. I'm being distracted slightly.
That's okay.
Because of the bottleneck, that animals are such coherent, unitary bodies. They work together. They have the same number of limbs, the same number of sense organs. Everything about the body works as a single unit. And that's one of the big differences between animals and plants. That in animals, the entire body works as a whole, as a unit, as a cooperative entity. Whereas in plants, you could think of it as much more of a straggling, almost like a society of leaves or of stems.
Yeah, you say the three reasons, back to the drawing board, orderly timing cycle, and cellular uniformity. I like this concept of back to the drawing board. Would you say
Yes.
that the fact that we go through this bottleneck, humans start as babies, this allow us to thrive more because there's more possibility for mutations and great new changes to occur?
Yes, let me take the back to the drawing board point. If you take something like a complicated organ like a heart, it's a very complicated thing. It works as a pump. It's got 4 chambers and so on. If you had to evolve the heart by taking an ancestral heart and changing it, actually changing the shape of it, it wouldn't work. But because you go back to a bottleneck, it's as it were back to the drawing board. You go back to the bottleneck. You start afresh. Each generation starts as a single cell, a single fertilized egg, and it grows by cell division. And so there is the possibility for the next generation's heart to be different from the previous generation's heart because it goes back to the drawing board. It starts from scratch.
Yeah.
If you imagine that evolution didn't work like that, if you imagine that each generation started out as the previous generation and kind of tinkered with it, like modeling clay or like a sculptor, then you couldn't get anything like the same complexity of things like hearts and brains and kidneys and wings. So back to the drawing board is a very important aspect of the bottlenecked life history.
Yes, I love that point. Now, you speak of these replicators, are these genes, these templates. Where do you think that the first genes came from? I've read all kinds of theories. Some scientists think that it came on an asteroid and hit the planet. If we go way back, do you ascribe to any of those kind of theories, or do you think it was a random process that just came to be at the beginning of planet Earth and time?
Nobody knows. It's one of the great gaps in our knowledge. We know that the origin of life had to be the origin of the first self-replicating entity. It probably wasn't DNA, but it was something like DNA. DNA is too advanced. It's been called a high-tech replicator. So it probably wasn't DNA, but something a bit like DNA. Now, as to whether that came from an asteroid or started out as a random accident on Earth, we don't know. I'm inclined to think it started on Earth. What has happened, however, recently is that we've discovered that asteroids bombarding the Earth do contain organic molecules of the sort which would have been useful raw materials for the origin of life. So once upon a time, theories of the origin of life thought that they had to explain where these organic molecules came from. They had to somehow be synthesized on Earth. We now know that the universe is full of these organic molecules because they hit Earth in the form of meteorites. So that part of what was originally a difficult problem, that part of the difficult problem is now solved. Complicated organic molecules, even things like amino acids, are present in rocks that are hurtling around the universe, or at least the solar system. And so that part probably did come from outer space. But I would be surprised if the first self-replicating molecule, the first equivalent to DNA, came from outer space, although it may have done. And it's one of the exciting areas of speculation in biology.
It brings a new meaning next time you see a meteor shower. You could wonder what proteins or amino acids are bolting in from across the globe, across the universe. Let me ask you this: memes. You're famous for this concept of memes, which are not DNA level replication, but they could be understood maybe socially. Can you talk on those for a second and how those apply to your book?
Yes, the last chapter of the first edition of The Selfish Gene, since the whole of the rest of the book had been about DNA, had been about genes, had been about self-replicating molecules as the basis for natural selection and evolution. I wanted to make the point that anything self-replicating could potentially do that job. Maybe in outer space there are other forms of life which don't have DNA, but they surely do have some equivalent, something self-replicating. And then I suggested, well, maybe we don't have to go to outer space. Maybe we can find self-replicating entities on our own planet. Memes, units of cultural inheritance, units of imitation. Humans imitate other humans. We imitate tunes that we whistle. We imitate clothes fashions. We imitate accents with which we speak. We imitate fashionable words. School children imitate crazes, favorite toys, that kind of thing. And so there is a sort of self-replication going on in human society. And it's possible that these memes, these units of imitation in human society, human culture, could be the basis of a form of Darwinian selection. the tunes that are catchy are the ones that get whistled and the ones that get repeated. So boring tunes don't get repeated. Good tunes do get repeated.
And the definition of good would not, it's interesting because, like you say, we have to be careful not to anthropomorphize, DNA.
Exactly.
It's not good, it's the ones that are efficient at passing on. So what makes
Precisely.
yeah,
The
go
very
ahead.
definition of good is that which gets passed on. Exactly right.
Would you say, so clearly fashion, music, now media, whether it be the internet and TV and movies, these are in some ways almost the hosts that are, they're almost the bodies that are passing this on so quickly, because without the internet, this meme replication of knowing every kid wanting to wear the same shirt or the same brand or listen to the same Kanye West or Lady Gaga, this wouldn't happen as well. So would you consider the media conduits, or what is the media in this sense?
Good. I mean, I think the internet is a fascinating new ecology, a new ecosystem for memes, enabling them to spread faster and more widely than was possible when I wrote The Selfish Gene, which was before the internet.
Yeah. Now, one of the memes, without a doubt, one of these concepts that spread has been through religion. I know you're not well, I don't want to put words in your mouth. Is there anything that you find redeeming in religion in the way it's currently taught, whether it be Christianity, Islam, Judaism? What is your take?
Well, a lot of very good people are religious. I would be a bit sad if the reason they are good is that they're religious, because that would imply that they are only good because they are attempting to suck up to their God. They are frightened of going to hell, or they want to go to heaven. That would be a rather ignoble reason for being good. I would prefer to hope that most people are good for other reasons, and there certainly is no evidence that religion does reduce criminal behavior or antisocial behavior. There are people who seem sincerely to think that if they were not religious, they would immediately go out and start raping and pillaging and stealing and killing. I'd like to think that that's not true. And I'd like to think that many of us who are not religious are capable of being just as good, just as nice, just as altruistic, just as cooperative as those who are religious.
You say, let us try to teach generosity and altruism because we are born selfish. Let us understand what our selfish genes are up to, because we may then at least have the chance to upset their design, something that no other species has ever aspired to. As we kind of close up here, altruism, charity, in light of the selfish gene, can you explain, there's different schools of thought on why we still exhibit, doing good deeds for others, maybe leaving a tip with a waiter we'll never see again. How do you explain altruism?
I think that's quite difficult. We talked earlier about ESFs, we talked earlier about tit for tat. There are primitive evolutionary roots to cooperation. You scratch my back, I'll scratch yours. People do things in the expectation of getting it paid back. And similarly, kinship. There are good genetic reasons for being altruistic towards your close genetic kin, because the gene that makes you altruistic is statistically likely to be shared by other individuals who are your kin, your siblings, your nephews and nieces, your grandchildren, and so on. So there are primitive reasons for being good. What's less easy to understand is why we're good towards people whom we're never going to see again. Like, as you say, you tip the waiter, you're never going to go back to that restaurant. And you are good to people who are not your relations, and you're never going to see them again either. I think I would appeal to the same idea as the rule of thumb that I mentioned earlier. Natural selection favored rules of thumb in our wild ancestors at a time when we lived in small bands, small roving bands or small villages, where everyone that you met would be somebody that you would meet again and again, and would probably be a cousin or some kind of relation as well. So there were good Darwinian reasons to be nice to everyone, because everyone was either kin and or somebody who could reciprocate at a later date. Now, once that rule of thumb has been built in, just like the rule of thumb that says like sugar or like sex, the rule of thumb is in there even though the environment has now changed. We now live in a world full of sugar. We now live in a world where we're surrounded not by kin, and we're surrounded not by potential reciprocators. But still the rule of thumb is there. The rule of thumb is in our brains, and it says, be nice to everyone, just as the other rule of thumb says, enjoy sex, even though you're using contraception. So the rule of thumb doesn't change just because we now live in a changed environment where it's no longer, in a Darwinian way, applicable. So we have a lust to be nice, a lust to be friendly, a lust to be empathetic, sympathetic, just as we have a lust for sex. And the two lusts survive from the time when they really were biologically relevant into the time today when they're no longer biologically relevant, but they're still there lurking in our brains.
I think they call that the mismatch. That's an evolutionary psychology. So we have these simple decision-making heuristics, and they stick with us, even though now we live in cities where most people will be anonymous. You see, that mismatch is really, as I ask you these questions, it's so much related to the second you take any organism, humans or otherwise, out of the environment in which their DNA evolved, all of a sudden their decisions aren't always as smart as they were in
No, that's right.
Yeah.
And I'm very glad of it, because I like to live in a world where we are nice and empathetic and kind.
Yeah. All right, a few questions as we end here. I'm gonna throw three relatively quick ones. What is your this is a step back from this more academic thought. Or what's your daily schedule? Diet, when you wake up, what you do?
Oh, I don't have anything very, very well organized. I work at my desk. I go to lunch in my college, New College. I'm a fellow of New College, Oxford. I go to lunch there. I work with my assistant some of the time. I take the dog for a walk. Nothing very, very exciting.
Could be exciting. There's a lot going on in your brain, so the excitement is right there, right? Okay, number two. You speak, I was reading about you had a mentor, Tinbergen, and I'm sure you've had different ones. The best thing a mentor ever taught you?
Oh, the best thing.
Or what stuck with you the most? It could be colloquial. It doesn't have to be a deep scientific theory.
I think that only ever trust evidence. For what you believe about the real world should be supported by evidence, not by personal feelings. You can't help having personal feelings, of course, and they are extremely important, but don't use them as grounds for believing anything.
Interesting. All right, I had one question submitted by another person. It was, do you believe in monogamy, that this is realistic? There's more divorce than, say, there was in the 50s. According to the theories of the selfish gene, is monogamy viable?
It's a difficult question to answer, because if you look at human societies, a fair number of them are polygamous and a fair number of them are monogamous. So unlike other species where you can say this species is definitely polygamous, like elephant seals, for example, are harem-based polygynous societies where you have a minority of males monopolizing a majority of females. There are some human societies in which that's true. There are other human societies where faithful monogamy is the rule. And so there is no easy evolutionary answer to the question of what mating system humans naturally and primitively adopted.
Interesting. All right, 2 quick questions left. Theories on the diet. Are you proponent of that we're omnivores, vegan, vegetarian, meat eating?
We are primitively meat-eating omnivores. That doesn't mean that that's necessarily the right thing for us to do all the time. And I have a lot of respect for vegetarians, especially vegetarians who don't eat animals on conscientious grounds.
Well, one quick question I've always wondered: how quickly can DNA change? I mean, is it? I heard once somebody say at the rate of 1% per 10,000 years. It sounded like not a good answer. Do you know that answer? Because people often ask me, well,
it's very variable. I mean, different. You're talking about mutation rates, and
yes,
they are extremely variable. In some cases, parts of the genome don't change for hundreds of millions of years, and they're maintained by natural selection. In other cases, they do change rather rapidly. So there is no general answer to that question.
Are humans, though, going to look relatively similar in 1,000 years, or do you think that there's now excluding things like computerizing our brain, but just if we were left to our own devices, but we have all the modern amenities, do you see, are we going to be a lot taller? Are we going to be way smarter? Or is there some cap on that kind of growth in let's say 1,000 years or 500 years?
It's a very short time to be asking an evolutionary question. Things like height are actually changing dramatically anyway over the decades. I mean, if you look over the 20th century, height in various peoples like Japanese, like Americans, average height has increased enormously. This is almost certainly not a genetic effect. This is almost certainly a environmental, probably nutritional effect. If you're asking about actual evolutionary genetic change, as I said, 1,000 years is too short a time. If you talk about, say, 100,000 years or 1 million years, that's the kind of time scale you want to be talking about for evolution. In order for that to happen, in order to see a consistent evolutionary change over 1 million years, it would be necessary for natural selection to work in a consistent direction for much of that 1 million years. That's rather hard to imagine with humans because our environment is changing so rapidly because of culture and technology that whatever it takes to be a good survivor, or in particular a good reproducer, at the present time is unlikely to be whatever it will take in 100 years, let alone 1 million years. So it's very hard to predict. If we send colonists out to, say, colonize Mars, where conditions are very different and where gene flow between the home planet Earth and the colonized planet Mars, where gene flow is very, very slight, then you might expect to see some evolutionary divergence.
All right, last question. Selfish gene. For a lot of people following me are entrepreneurs. They're people interested in being successful. Someone listening in, from all the decades studying this fascinating concept of us humans at the replication level, any advice you would offer, more practical, on being financially more prosperous, both as an individual and as a society? What do you think?
No, I would prefer not to do that because I would like to emphasize in conclusion that the title, The Selfish Gene, emphatically should not be interpreted as anything to do with selfish individuals. Selfish genes are just as capable of building altruistic, cooperative, generous individuals under the right conditions. So that I emphasize this because the book has often been misunderstood because of the title.
Yeah.
As some suggesting that humans are selfish, or even advocating that humans ought to be selfish.
Like you,
And it's
you know.
neither of those things.
So it's conscious capitalism, like you mentioned earlier, that's really what you're a proponent of. Awesome. Well,
Well, yeah, I would like to emphasize that the book is supposed to be um, an imaginative explanation for the whole of life. It's not really about selfishness.
yeah,
It's about life as a whole, and it explains how everything about life, its complexity, its beauty, its elegance, its illusion of design, everything comes about through the natural selection of genes, which are selfish only in the sense that they are working for their own survival. And working for their own survival is in many cases equivalent to working for altruistic, unselfish individuals.
yeah. Like Rabbi Hillel said, if I don't love me, who will? But if I only love me, what am I? So we're
Yes. Okay.
well, Professor Dawkins. Thank you so much for your time. If people want to follow up with you, is there a website? Is there a new book out? What's the best way to...
Okay, well, the website is richarddawkins.net.
Okay.
And new book, well, the second volume of my autobiography, which is called Brief Candle in the Dark, and I got, as a matter of fact, the very first copy of that arrived in the post today. So it's not yet published. It will be published, I think it's on the 12th of September or thereabouts, sometime in September anyway. So that's the second volume of my autobiography. The first volume, which was called An Appetite for Wonder, covered the years from childhood until the selfish gene. And the second volume, Brief Candle in the Dark, covered the years from the selfish gene until the present.
Well, thanks so much, Professor Dawkins. I appreciate you being here explaining the book, The Selfish Gene. For all of you who have not read it, it is on my recommended top 5. Professor Richard Dawkins, thanks so much.
Thank you very much.